Good morning, guys, of grade 8. Today, inshallah, we're going to continue section 2 of chapter 3. We're still talking about how to identify mineral. So last time we said that we have different minerals, and all these minerals, they share general characteristic that they are solid, natural, have a fixed chemical composition, have a crystalline shape, and all this we know this. But then we said we must have some properties, or we need some characteristic that we could depend on to classify or to differentiate different elements or to identify certain minerals. So regarding to this, we start to study some properties that we could use to identify a mineral. The first property we studied color, then we studied streak and the cleavage and fractions. So all these properties, okay, plus luster, yes, the reflection of light. So these four properties we said that we could depend on to somehow identify the mineral. Today, inshallah, we're going to continue what are the properties that we can use. So the fifth property we have today, we call it hardness. So the word hardness, what do you mean by hardness? So simply you can predict it from the name hardness. Hard means how much the substance is hard, how many or represent how much of the hard is not easily to be scratched or broken. So like this, okay, we see that hardness, a mineral's resistance to being scratched is called hard. So that means how much this mineral is hard, it even is not that easy to be scratched, we call that hardness. So of course different minerals are not equal in their hardness. Some minerals are soft, they could easily be broken or they could easily be scratched, okay, once they fricked or wrapped with another material, while some minerals they are very strong. So regarding to this, or to be clear how we could differentiate to hardness, scientists state a scale, or they made a kind of scale that represent the hardness of minerals. So they make a scale that represent from 1 to 10. Okay, 1 represent the most or the softest mineral ever. Okay, and 10 represent the strongest mineral ever. So whatever you have a mineral, you don't know what this mineral. So you could test its hardness by scratching this mineral with one of these of this scale. For example, let's take an example. So here we're gonna find that's the scale of hardness. We call this Mohs scale. Okay, we're going to the scientist who made it. So here are arranged some minerals, okay, in order from 1 to 10 that represent, or from 1 to 10, the hardness increases, which means the most soft or the softest mineral ever is talc, okay, that's represented hardness equal 1, and the most strongest one is diamond, which represented by 10. So if you have a mineral that you don't know what this mineral, so you are gonna scratch it with talc, okay. If the streak of your mineral, okay, is already on talc, so it means like this, your mineral hardness equal to 1. If your mineral already scratched talc, that which means the streak of the talc or already found, or the powder of the talc is already found in your mineral, so your mineral is stronger than talc, so it's hardness more than 1. So we're going to start with, try it with gypsum. So if already the gypsum is not able to scratch your mineral, so it means your mineral hardness is more than 2. So you pass to calcite and so on, okay. So you could know how much, okay, the hardness of your mineral regarding to that scale, okay. So we could find that diamond is the most strongest one, which means it's not be able to be scratched by whatever any mineral else, okay. So that means diamond is the most strongest one. That's why we use minerals, or scientists use minerals, and they put it in the drills which they already start to drill in rocks, okay, during mining or searching for different minerals or different or petroleum or something like this. So why? Because diamond is so strong and it could break, okay, or it could scratch any other mineral. So here like this hardness, okay, that represent how much strong the mineral is, or how its ability to resist scratching, okay. And we know how we could use hardness, okay, as a property to differentiate between different minerals. This the other property we have, density. Okay? So we know density before. We know that density is kind of relation between mass and volume, or the amount of matter in a certain volume. So simply density equal mass over volume. Okay. So here we find that the measure of how much matter is found in a certain volume or amount of space. Okay, we call this density. Of course, density is a physical property which is considered to be a unique identity for each matter. That means there is no two matters in the world they have the same density. So like this, okay, we're gonna find that equal sizes of different materials, they have different masses, and the equal masses of different materials, they have different size, so they never, okay, have the same density. So density is considered a good property that we could depend on to differentiate between different minerals. So like this, different minerals have different densities. So like this, or Till that moment, okay, we already studied color, luster, streak, cleavage and fractures, hardness and density. Six properties are enough to recognize or to differentiate between different elements, because there is not two minerals they are going to share all these six properties. They must be different at least in one of them. So like this, we could differentiate between different minerals based on these six properties. Okay. Plus that, there are some special properties which consider to be unique or just for certain minerals. That means some minerals may have these properties or others may not have. So whatever any mineral it could be, okay, the six properties could be applied in all the minerals. So we could depend on them to differentiate. But there are some extra properties for certain types of minerals which ensure, okay, the identity of a mineral. What are these special properties? Let's take an example. So here we said that fluorescence. What I mean by fluorescence? The ability of light to glow under ultraviolet radiations. That means some minerals, when they are exposing to the ultraviolet radiation, they start to glow, okay, or they start to giving, okay, a kind of light, or they imitate light. So like calcite and fluorite, okay, both of them they are able to do this. So that's special kind or special property for fluorite and calcite, that they are able to emit light under ultraviolet radiations. Okay. Another thing, chemical reactions. What I mean by chemical reactions? Some kind of minerals they could react, okay, and producing bubbles, okay, or making like bubbles are produced that they make a physical reaction, okay. So that's, for example, like calcite. Once it react with any acid, okay, once you put a drop of acid like vinegar, for example, or hydrochloric acid, sulfuric acid, whatever, any acid that is gonna fall on chemical or calcite, we're gonna find that calcite start to making a kind of bubbles, that because of carbon dioxide gas is produced. Optical properties, that some minerals, okay, some minerals, once you get a sand or a slice of these minerals, you find that they have some optical characteristics. What I mean by optical characteristics? For example, it could magnify, okay, or it could just reflect or refract the light. So like this, it has some chemical properties, okay. For example, here a thin piece of calcite, okay, it could cause a double image, duplicate the image, which means somehow it's a kind of reflection and reflection happen inside this piece of calcite, causing the image to be double. Magnetism, first from its word magnet, okay, so it's ability of some minerals to attract some objects which made of iron, okay. So that's, for example, like pyrite, okay, pyrite, okay, and some other magnetic ores, okay, they also kind of minerals which able to attract the objects which made of iron. Taste, okay, and of course that is not common, okay. So taste for some minerals, okay, they have taste like halite. Halite is a table salt, so it has the salty taste, but actually the taste is not recommended to be a property that we depend on, because it's not good to taste different substances, different, because maybe one of these minerals contain toxic material or something like this. So even in lab, it's not fair to taste materials, okay. But also it could consider be as a kind of special properties for some kinds of minerals, not of course just few number of minerals that they have a kind of taste, okay, like as example. Finally, the radioactivity. What I mean by radioactivity, we said that minerals that can, okay, or that they contain radioactive material, okay, like uranium, radium, okay. So we could detect the presence of this by kind of device. We could Geiger counter, okay, or Geiger device. The Geiger device, it just measure or sense the emission of radioactive material or radiations. So we could use the Geiger once we expose the mineral to the Geiger counter. If just give a certain reading, it means this mineral already could imitate some radiation, so it contain radioactive material. So like this, okay, it's a special property for some kind of mineral. So like this, guys, we know the different properties that we can depend on to classify or to identify a mineral. So first, we pass with the normal six properties that we studied: color, luster, streak, cleavage, and fractures, density or density, sorry, and hardness. So like this, as we said, of course, okay, not all the minerals they are sharing the same properties, or they are not the same in all the six properties. They must have a difference. For example, they maybe we have two minerals, they are having the same color, maybe they have the same luster, maybe they have the same cleavage and fracture, but of course they will be different in density. For example, they will be different in uh, hardness, so lightness. Okay, at least they are going to be different in one of these properties. So like this, we could identify or differentiate between different minerals. Plus that means that some minerals they have extra properties, like what is shown in your the slide in front of you. So they are just special properties for some minerals. So that means I can't searching for these properties in all the minerals. I just use them just a kind of confirmation for the identity of the mineral. So that's our section, guys. Okay, please achieve your SMS for the plan of that week. Okay, and find your assignments and your time. And if you have any question, you can contact